Hi everyone, my name is Shane Evans and I'm here today to talk to you about automated testing in gaming, and more specifically how we can improve automated testing in gaming, which is what we at GameDriver specialize in. So, as Shigeru Miyamoto once said, a delayed game is eventually good, but a rushed game is forever bad. And what is meant by this is you can always improve on the quality of a game. Nintendo is synonymous with high quality games, and they have a very well-known program called the Nintendo Seal of Quality, which is an actual program in which they verify the integrity of a game before releasing it to their customers. And this has led to some really amazing titles over the years that we're all familiar with, such as Mario, Donkey Kong, and Zelda. But not every company is a Nintendo. And so what we've seen over the years is this sort of evolution of how we engage with the application world. From that, the evolution of how we test those applications as well. Starting with where I started my testing career in the mainframe era, where we tested things very manually. And we had to basically go through the application like an end user would. Leading into client-server applications, where more of a record replay technology came into play. This is around the early to mid 90s. With the advent of web and Web 2.0, the expression of applications changed to a more standardized interface using the DOM and JavaScript. And therefore we started to focus more on the front end of those applications to be able to automate testing. And finally, the most recent evolution of applications, which is still underway, is the proliferation of mobile devices and applications being more integrated with our day-to-day lives, incorporating things like geolocation and even biometrics and wearables. This has really led to a change in the way that we test those applications, because they have to no longer exist in isolation, but to exist in the real world. And therefore we have to take into consideration all of those factors as we test those applications as well. The next big application evolution is one that we at GameDriver believe very strongly in, and that is the immersive experience. More and more we're seeing applications like gaming moving towards a more immersive experience using AR and VR, for example. And this is not limited to gaming. 3D, 2D applications are being built using gaming technologies so that they can provide a more immersive experience to their customers. And we're seeing this everywhere from financial institutions to government and to entertainment industries. So this extends well beyond the sort of realm of gaming in general. But we're going to focus a bit on gaming here, because everything that applies to gaming as a technology will apply to these immersive experiences as well. So one of the challenges that we face with application testing in the past is that this wave of innovation kind of washed over us very quickly. We did not anticipate, if you will, the effect that it would have on application delivery and application testing quite early enough. And therefore there was always this notion that the next big wave is coming. And by the time that we really adapted to it in the realm of application testing, it had washed over us already. So we need to really be careful of that in the case of immersive experiences. We completely missed the boat with mobile, and there's so many things that are just now catching up in terms of mobile technology and how those applications are delivered and tested. Technology is an evolution, it's not a revolution. So what happened with the Web 2.0 and mobile experience will happen again with immersive experiences. We need to get on top of this. And testing, in order to evolve to this next big thing, needs to anticipate those changes, but also take everything that we've learned from the past and apply it going forward. So rather than reinventing the wheel and trying to come up with fancy new ways to do application testing for immersive experiences in gaming, we just need to build on top of what we know. The problem with gaming and testing in gaming in general is that game testers lack tooling. So all of the development process before and after testing uses very sort of modern tools, automation, and practices, except for testing. This critical stage is completely manual in most cases and has been that way for well over 30 years. So what we have is this sort of phased approach where even the conceptual design of applications and games uses very modern tooling technologies. Development follows very standard practices of Agile and DevOps. The launch experience is fully automated, from everything from the delivery of bits to the customers to the monitoring of applications, the monetization, the value-added services around those games, and support continues along those lines as well. But testing, which sits squarely in the middle of all this, is primarily manual. It's slow and inconsistent. We use programs like beta tests, whether they're open or closed, which is an inherently risky proposition. If you're opening your game to outsiders before it's done, chances are, and this has happened and continues to happen in the industry, you're exposing your IP to competitors, whether or not you believe it to be true. And there's increasingly low coverage in testing games in this way because games, as they grow and become more immersive, the broader the scope, the broader the world, the broader the experience, which is what customers are asking for and what is really driving the market forward, it becomes increasingly difficult to test everything manually. There's just too much to do, too many combinations, too many paths to go down. And so we need to adapt. I want to take a step back for a moment and talk about the modern testing lifecycle. In terms of testing, this is pretty much a standard practice in other parts of application delivery. So everything from web and mobile applications to client server applications, which still exist in the modern enterprise. This is a sort of short description of the way that applications are testing. And I wanted to frame it in a way that makes sense for gaming. So what are we talking about when we talk about automated testing? It's not just the sort of automation of steps within a test, but it's the entire process. So let's start with something simple. Here we have application or game changes, and we're going to look at three very important aspects of testing: time, cost, and quality. And the perennial problem in testing is that QA and testing in general needs to satisfy no more than two of these requirements. So you get to choose two, and no matter what you choose, one thing is going to fall short. To give you an example, faster delivery at a reduced cost, right? So we're delivering the application faster without spending too much money, means less focus on quality and low test coverage in each release. What does that mean? We have maybe fewer testers. We don't have the amount of time that we need to test each and every release, and therefore our coverage is low. We're only testing the essentials in this case. Chances are quality is going to suffer. If we choose a reduced cost and increased quality and coverage, right? So looking at the bottom two, this tends to be a much lengthier process. Let's say we have, a team of 10 testers, and they're going to iterate over the application or game over and over until everything is done. This can take a very long time, and it can be very expensive. High quality and fast delivery. So if we want to, test everything and do it quickly, means we typically throw more bodies at the problem, which is very expensive. Not to mention, we need to deal with things like the environments, the delivery platforms, whether it's consoles, mobile devices, wearables, and repeating this for each and every part of the process can be very expensive. The solution? Reduce the scope of testing. Reduce the scope of changes in your application so you deliver less but more frequently. Automate testing and execution of those tests from the continuous integration system. So as application changes or game changes are brought into the testing environment, we continually add to the automation of those tests, and we're able to increase coverage as we proceed with each release. And lastly, remove external dependencies, internal and external, whether it's the wearables, the consoles, the mobile devices. We need to somehow capture these and make sure that they're covered without replicating test environments each and every time. So, what do we automate in testing? Well, it's typically broken into three areas: unit testing, API testing, and UI testing. The number of tests, which is represented by the breadth of this pyramid, is contrasted by the cost, coverage, and execution time of those tests. So everything at the bottom of this pyramid, the unit tests, which should make up the majority of tests, this happens during development, or it should be happening during development. This should be testing the atomic pieces of functionality within your code, making sure that the calculations are correct, that when we click on a button that it does what it's supposed to do, and so on. API testing, which is a little more expensive, a little more difficult to test, and takes a little more time, is when we start to piece these components together. When you have services behind the application, when you have multi-player capabilities, for example, we want to make sure all of those APIs are responding as they should in a more integrated system. And UI testing, which is the most expensive, this represents the manual testing and often takes the most amount of time. This covers the majority of functionality, but can be very difficult to execute. The ideal approach, or the one that often gets promoted in these sort of how-tos for automated testing, tend to take the approach of start with your unit testing, layer in API testing when that's done, and then focus on your UI testing. And this approach would seem to be accurate over the course of several releases or builds of the application before releasing, that by the time you get to a stage where UI testing is covered, everything beneath it should already be done. Unfortunately, this isn't how applications are built. The reality is that everything gets built kind of in parallel, and we end up having to deal with small portions of testing and automating those tests each and every phase of the release. So we tackle some initial unit tests, API tests, and UI tests, and then we automate those things for one release. And then come the next release, those things are already covered and we're building on top of it, and we increase our coverage. And then we check those into the same release and code management systems, excuse me. And then by the third release, we've got quite a bit more covered. Of course, you're never going to quite reach 100%. It's a lofty goal, and it's something that most organizations don't do. But if you're able to automate the things that are repetitive and that get executed each and every time you build and test that application, then you're going to be in a much better place after a few releases. So coming back to testing and gaming in general, games are a big business, and I don't think that's going to be a surprise to anybody paying attention. The cost of poor quality is fairly acute in this industry. First impressions are everything. So often the time to deliver is driven not by the quality of the content, but by things like pre-orders and monthly subscriptions. A lot of organizations or a lot of game developers who accept pre-orders are kind of on the hook to release roughly when they said they would. Otherwise, they can't recognize that revenue. As I mentioned earlier, access to beta programs carry a pretty significant risk to reputation and IP theft. So while it's a widely accepted practice in this industry, it's something that we really need to consider as we move forward, because as games that get released tend to kind of look and feel very similar, we want to avoid that sort of thing. Otherwise, we're leaving money on the table in terms of potential revenue. And lastly, as I mentioned, first impressions can make or break a studio. I often give the example of No Man's Sky, which upon release, after years of hype in the industry, had a pretty disappointing launch. And I will say that the game has gone on to really show massive improvement since that initial launch, and the player base has grown substantially. This could have been another billion-dollar success story if that game had launched with the quality of a Grand Theft Auto 5 or a Call of Duty Modern Warfare 2. In more recent news, and I'm sure most of us are aware, Cyberpunk 2077 broke all kinds of records in terms of pre-orders, number of units sold, and since putting this slide together, has even gone on to beat the highest 10-day revenue of any game released on the PC. So the problem here was that the reviews were mixed between PC and consoles, going so far as to require refunds to be issued on the PlayStation 4. And you can see here from the Metacritic reviews the huge gap between the reviews for the PC version and the console versions. I personally enjoy this game quite a bit, and I can't wait to see what happens here, and I'm sure it will go on to see great success. But it just underscores the fact that quality for not just one platform, but across all of the platforms that you release on is critical. So what can we do about this? GameDriver was introduced to be the first automated testing solution designed specifically for the gaming industry. We offer a simple, intuitive API targeting developers and testers to really introduce automation from early on in development and continue throughout the life cycle of the game or application. We provide the ability to record or replay for ease of development. It's designed for cross-platform execution. So when we design and develop on one platform, we can test that the same functionality exists and performs as it should across multiple platforms, ensuring a quality experience across the board. And it's engineered to support most major game development platforms. Currently, we support the Unity engine, but very soon we're hoping to announce the support for Unreal, Lumberyard, and other platforms. And it's a single solution for 2D, 3D, VR, and AR, etc. Anything that's built on top of the gaming engine can be tested with GameDriver. So now I'm going to drop into a demo. And what I'm going to show you here is very quickly how easy it is to incorporate automated testing into your game. We're going to use an example from Unity, which is the 2D game kit offered on the Unity Asset Store. Simply go to the Asset Store, search for the 2D game kit, and you can import it into any project. So this is a very simple project. It has 5 zones, 3 objectives where you collect keys, and then there's a final boss that you can fight at the end of the game. And it offers tutorials for how to build out levels of your own. So it's a great learning tool. And what we're going to do here is we're going to simply add the GameDriver package by importing a custom package into our game. And I select from the latest version for my release of Unity here. And then we simply hit import. Now, other solutions depend on heavy instrumentation of the game, including Unity's own unit testing solution, the Unity Test Runner. There's quite a bit of coding within the game itself that's required. Now that's great for unit testing, and it's a best practice to use this, but we take a slightly different approach when it comes to automation with GameDriver. So once this package is done, I'll show you how quickly and easily we can get started here. We have all of our assets imported to our project now, and I simply add an empty game object to the starting scene of my application. We're just going to give it a name here. And I add a single component to that object, the Unity agent. Here's everything that we need to configure the agent within the project. I'm going to use the Unity logging to show events as they're executed, and we're going to capture input events so that if I was to play through this game manually, I can see what I'm doing and then use that information to build my automated tests. And that's it. This is all I need to do from the game's perspective in order to enable GameDriver for automated testing. I'm going to then jump over to Visual Studio for a moment, and we're going to do a very simple test here. I've created a NUnit library or a .NET library for version 4.71, and I've brought in the NUnit framework, NUnit console, and NUnit libraries for the heart of testing, the framework itself, which we will use here, where you see things like test fixture, one-time setup, etc. And then I brought in the Unity API as a reference here so that I can expose those features of the GameDriver API within this test. And whether you choose to store your test assets with your game project and check in the code together, or you store it separately in a separate repo, is up to you. We provide tutorials for how to do both of these on our website. But what I'm going to do very simply here is under one-time setup is I'm going to connect to the game. So when I start typing API, you can see all of the methods that are supported by GameDriver, things like capture screen, checkpoint status, click object, get object field value. And all of these are covered in our documentation. In this case, I'm just going to wait for game, which is going to connect me to the Unity editor, and we're going to connect to localhost here. Now, what that implies is that we're actually able to connect to other machines to run these tests as well. I can create my test automation on one machine, either Windows or a Mac, and I can execute that across multiple machines. Next, I'm going to just wait and bring in a bit of wait time. This is 1,000 milliseconds, and this allows the GameDriver engine to catch up with the game itself while we're waiting to start the play process there. Once we've connected to the game, I'm going to do a few things here. I'm going to enable keyboard hooks, and I'm going to enable mouse hooks. And this just allows me to inject input into the game as if I was the end user. Once that's done, I'm going to wait another few seconds here, maybe 2 seconds, before we get started with our test. Now, the next step would be for me to do something in my test, which is why I've called this test do something. So I'm going to jump back to Unity for a second here. And I know that in order to start this game, once I launch it, and I'll just give you an example here, when I click play, the first step would be for me to click start in this game, right? So I might not know where that start button exists, but I know that I need to click it. I would simply search for start button here, and I can see the start button. This is exactly what I'm looking for. And I can click on this object. I can do any one of the activities that the object is enabled for, but also I can query any of these fields here within the inspector window into my test. But for this test, I'm just going to click on it with my left mouse button. And in order to find this object, I'm going to right click it and go to hierarchy path. This is something that's included with the GameDriver application or plugin for Unity. And we're just going to use the relative path to that object. And if I scroll down in my log here, I can see all of the things that are happening in my game as we start up using the GameDriver engine. And the very last thing is that path to that object, this start button. So I'm going to highlight that and copy, and then come back to my test for a second, and I'm going to insert API click object with the name that I just copied out of my game project. And then we want to, and it's already picking up what I need to do here. I need to click on it with a mouse button, and we're going to select the left mouse button. Now there's a wait period, which defaults to 60 seconds, but I don't need to enter that, it's optional. And then I'm going to again wait for 1 second for that to happen. Now, a good practice, jumping back for a second, would be as I connect to this game to make sure that I am connected. So I'm just going to insert one more method call here, and it's wait for object. We're going to wait for this object to appear or to become active in the game before we continue on from that initial connection. So whether or not we wait 2 seconds or 5 seconds or 10 seconds, this wait for object will pause and wait for this object to appear for a default time of, I think it's 60 seconds, and we can set that to be even longer or shorter if we like, before we move on to the next step. Lastly, before I run this example test, I'm going to tear down the test. So what happens when the test is completed? We're going to do this one-time tear down. So we're going to disable keyboard hooks. We're going to disable mouse hooks. We're going to wait another 1 second, and then we're going to quit. And this will disconnect my test from the game and close the play mode in the editor. I'm going to save that, jump back for just a second, make sure that I'm ready to go here. I've got my agent ready and I'm set. So let's make sure this clears on play. And I'm going to run this. Jumping back to take my hands off the keyboard and make sure that it does what it's supposed to do. So we can see as the test starts to run, it puts Unity editor into play mode, and then it clicks on that start button. We can also see in the top left-hand corner, which went by fairly quickly there, the time and date and the mouse coordinates. That's another feature of the GameDriver agent, which tells us that the GameDriver agent is running during replay. So I can see from my test, my very simple test here, that my test was successful. We successfully clicked on the button, which we could see visually. So I didn't need to come in here, but just to show you what that looks like. And then we can see in the output that the test do something was successful. So now I'm going to give a little more advanced example. We're going to run a test that I've created previously, which does play through actually a few of the levels within this game, just to show you what GameDriver is capable of from an automation perspective. Now, keeping in mind, this game is not optimized for the platform that it's running on. It's just a sample game kit. And so there's going to be a difference between how well the game runs on this laptop that I'm running on now versus my high-end gaming machine. And so things like the number of frames per second are going to have an impact on the outcome. Everything in Unity happens in update cycles. So depending on how fast the game is running, more or less will happen within that update cycle depending on the performance of the machine. So we have to do things like pad or calculate our input using things like the frames per second. And I'll just scroll past quite a bit of code here, for example, and show you when I press a key, which is the S key here, and then the next parameter in this method is the number of frames. I might take the frames per second, which is using the API get last frames per second as a method, as input for that key press. Therefore, I don't need to say how many seconds do I want to run it for. I can say, run it for however many frames run in a single second, or I can multiply or divide that number to get roughly the input I want. You can see there's a lot more going on here, but it's actually quite a simple test. And I'll quickly walk through it here without scrolling too fast. So I've added a few things. I've parameterized the test host so that I can run locally or remotely. I've parameterized the test mode. Do I want to run in standalone or against the IDE? And a standalone is a build for the platform that I'm executing on. And if we're running on Windows, we need to take certain other things into consideration. I've got some other integrations here for things like Applitools Eyes, which is another integration that is supported by GameDriver, along with Backtrace for error reporting. And I'll skip past the configuration of that integration, but we can see here if the test mode is standalone, we're going to use that wait for game method that I mentioned earlier. And if the platform is Windows and we want to run in standalone, we launch with this command. Otherwise, we're going to launch with this command on a Mac. And then we can do our enable keyboard and mouse hooks, do things like set timescale. We can execute tests in double time or even higher. Of course, this is going to affect the replay of the game quite considerably, but it is supported. We can capture screens to show us that what appears on the screen during the test is what we expected. And then as I did before, I'm waiting for an object to appear, the start button, and when it does, I'm going to click on that start button before we get started. Now the next two tests, as you can see here, I've got test zone 1 and test zone 2, provide very deterministic outcomes. The goal of this test is to gather a key, and in order to do that, I need to navigate through the first zone, into the second zone, and then find the key and grab it. And to do that, I'm using objects within the game as kind of reference points. For example, in the first zone, I have this info post object, not the first instance, which would be 0, but the second instance of that info post, which is going to tell me where I need to go. And then as part of this test, I'm comparing the position of get object position for player Ellen on the x-axis, so 2vector3.x, to the position of the info post, plus or minus 1 on the x-axis. And if I'm at the post, essentially at the end of this test, then I need to press down and jump, which is the very first thing that we do here within this while loop. And the while loop is simply saying, while we're on active scene zone 1, do these things. until we get to that info post. If we're too far to the left, there's a gap. So if we're on the left of this gap, we need to find a way over. So we do another comparison between the character's position and a known position within the zone. And if we're on the left of that, then we're going to jump. If we fall in the hole, we need to jump back out to the left and then try again. And then once we've crossed that gap, we're going to move to the right until we get to the info post. And if we've passed the info post, move to the left. And if all of this is successful, we should be in zone 2. Now, before I hit run, I'll just say the next zone, our goal is a little bit different. So it's very similar in the sense that we're comparing positions and using those for navigation. But this time, while we're looking for the color of an object to change on the screen. So this is the key canvas, which is going to be shown on the top right-hand corner of the game when I click replay or when the test replays. And a component, so this UI image component of that object with a property of color is going to equal RGB alpha of 0. And it's this, while this alpha is 0, we continue with the steps below. So again, while we're on either side of that key, shaving floating precision for accuracy, if we've hit the key, we're going to break this loop. If we're to the left of the key, move right. If we're to the right of the key, move left, all the while jumping so that we can get to the key which is on a pedestal. And we do this until we get the key color will change, right? So we'll see that alpha blending turn from 0 to 1, and then we exit the zone. So that's quite a long explanation for what took me probably 45 minutes to an hour to build in terms of the automation. So let's see what this looks like when I hit play. Jump back to my game, and again, I have my hands off the keyboard here. Once again, we can see the top left-hand corner of that game show the agent is running. We can see the keys as they appear here in black. And then in a moment, we'll see the player start to run. She made it across the dip on the first jump, which is actually quite uncommon during these demos. Sometimes she falls in 2 or 3 times before she makes it across, which gives me a little more time to talk. In this case, we made it to the info post pretty quickly, press down and jump. We're now into zone 2, and there was a quick pause there, which allows me as a tester to show that I can actually pause the game during replay. She jumped over to the left a few times, grabbed that key, and we can see the alpha change from 0 to 1. Which now shows the key as visible. That's the only other indicator visually that I was able to use as a tester to verify that this functionality was satisfied. Now, because we exited the loop on pretty much the first try, a couple of the additional steps run beneath, which is fine. We still exit the zone as intended. And now she's going to finish off her actions, which was to run to the right. And now we're in zone 3. We have the key, and our test was successful. So I come back to my test here, and we can see that zone 1 was satisfied, zone 2 was satisfied, and down below in my output, which is all captured in the logging for later verification, or if you're running this test from Jenkins, you'll see these tests as passed or failed. We can see the test for zone 2 was successful. We did the key get message. We output some information for me as a tester to understand the frames per second performance of the machine that I'm executing on, the key coordinates, player coordinates, and so on. I've got another method in here that outputs all of the active objects within the active scene so that I can see everything that's running, and I just insert that for my own purposes so I can use it for later debugging or additional instrumentation or testing. And the first zone, we can see all of those things that when we're going to jump over the gap, the positions that we were using to compare, the info post being found, and then finally when we drop down into the next zone. So we can provide a lot of information to the developers here that will tell us exactly what's happening during test execution. So I'm going to jump back to my presentation here. And essentially what we've done at GameDriver is we've taken everything that we've learned within web and mobile testing, client server applications, all of this years of experience testing applications in the enterprise space and brought it to the gaming space, not just for gaming, but for all immersive experiences. This allows for repeatable, consistent testing, a huge increase in productivity where we can, over time, automate all of those things that take a lot of time to test each and every build for each release, put those into an automation library, and then focus on new functionality, which is going to increase our coverage, increase our tester productivity, and overall the quality of our product. And then finally, reducing waste. So each hour that goes into manual testing is gone once it's consumed. We've seen companies save as much as 85% of the time spent testing using GameDriver. GameDriver really enables video game developers, testers, and producers to automate playtesting, improving time to market, test coverage, and overall quality and revenue. And we believe that this is what's necessary in the gaming industry today. We support PC and Mac, iOS, and Android's coming soon. We support multi-host testing. So whether you're testing locally or on the private or public cloud, we've got you covered. And the benefits of automating your testing are significant. So reducing the cost of manual testing, lowering your defect rates, and increasing your potential revenue, improving your time to market. So fewer delays as we approach a release date can be expected by introducing automated testing early in development. And lowering the overall maintenance cost. The less manual testing we need to do for each and every release, the less that you're spending. So over time, you can start to see the curve of cost for testing start to go down, but also that the benefits increase with time. I want to talk briefly about how it works. I'm just going to build this out briefly to show that the GameDriver agent is connected with the API, and this is all that's inserted within the game. So when it comes build time, whether you're deploying to a PlayStation, Xbox, PC, Mac, Windows, or Switch, you simply pull out the agent and everything's ready for launch. There's no heavy lifting that needs to be done building the testing, getting the project ready for testing, or in getting it ready for production. So as I mentioned, some of our customers are seeing a massive improvement in their testing cycles with the result of using GameDriver, up to 85% reduction in time spent doing manual testing. And this is from a VR company that's using Unity for not gaming, but for retail, which allows them to allows their customers to build out virtual spaces in VR so that they can test those spaces before making them real in terms of building those retail spaces for their customers. And lastly, I want to invite everybody to give GameDriver a try. Again, it's an easy to use, powerful interface for automated testing in 2D, 3D, AR, and VR projects, not just limited to gaming. It's integrated with the overall continuous delivery pipeline, and it really streamlines your build verification testing and delivery. This allows your developers and testers to increase test coverage while improving quality and time to market overall. I want to thank you for your time and happy testing.